Hello everyone, and welcome to today's webinar, Crime Web Decoded, Unraveling Hidden Networks with Pooled Data and Graph Analytics. So my name is Jean Villedieu, and I'm a co-founder at Linkurious, and for today's session, I'm joined by Anne-Marie and Brady. So Anne-Marie is Director of State and Local Services at RS21, and Brady is Director of Software Development at RS21. So first, a quick word about Linkurious. The company was founded in 2013. We are a team of 50 plus employees, serving more than 10,000 analysts who are using our software on a daily basis to conduct complex investigations. And we have two offices, one in France and another one in the US. We have 100 plus clients throughout the world, and those clients span across the public sector, where we are working, for example, with the tax agency in the UK or in India, but also the commercial sector with partnerships with Airbus, real money transfer, or Zurich Insurance, among others. So let's get started with the webinar, and I want to present briefly the agenda. So we will talk about graph analytics and law enforcement, why graph analytics makes a lot of sense to law enforcement investigations. Then we'll talk about a mission to improve community safety and RS21. Afterwards, there will be some slides regarding the integration between Linkurious Enterprise and the RS21 platform, and finally a bit of a demo of the platform. So that's it for the menu for today's webinar. Let's get started. So first, graph analytics and law enforcement. So law enforcement investigations can bring real data changes. The first thing that we may think when we're talking about data changes in law enforcement is maybe just the sheer scale of the data that law enforcement professionals have to deal with. That's definitely one aspect, but that's not the only one. Because traditional data sources, financial records, financial records, are still very much relevant, but to these data sources, now the law enforcement investigators need to also add other data sources, such as data from social media, data from IT and cyber, and more. And there's a big challenge beyond just the sheer scale of the data in bringing together these different data sources to conduct effective investigations. Because if you're doing an investigation, a small-scale investigation with just a couple of persons, just a single source of information, such as phone call records here, it's not too complex. It's actually fairly easy to understand what's going on. We can scale that a little bit, add more data sources. For example, add financial records, and it gets slightly more complex, but that's still manageable, I would say. But what if we bring more data sources to the equation? What if we go deeper than the first level relationships of each person, and we start really analyzing the indirect connections with information that's scattered across different tools, different tabs? The investigators very quickly risk wasting their time or missing critical cues, and that's really a big challenge. And from one perspective, there's really a limited set of options to actually understand those connections, conduct link analysis as part of the investigation process. We see three main options. So first, those connections, they can be analyzed manually with lots of room, I would say, for missing some critical insights. It's also fairly cumbersome and time-consuming to try to reconcile different data sources manually. And finally, it doesn't really scale to large data sets. So that's one option. Another option is to use some of the legacy link analysis software. The problem is that they are very much focused on small-scale data. The UI can be a bit complex, and they're not well adapted to modern environments and to browser-based environments. So once again, there's a bit of a risk to lose some insights, but also it's not really scalable to large big data sets. So that's option number 2, and at the other end of the spectrum, there are also some intelligence platforms out there that are available to intelligence agencies, but they can be very expensive and also quite taxing in terms of resources and in terms of expertise. So it's not necessarily available to a lot of organizations. So that's why at Linkurious we think there's room for more. There's room for improvement, and what we are doing is that we're trying to bring modern link analysis to law enforcement. And we are combining the power of graph databases that make it possible to tackle massive data sets with very intuitive UI for advanced link analysis. The idea is to have something that's both scalable, but also easy and cost-effective. All of that is packaged in our Linkurious Enterprise product, which is an investigation platform that leverages graph analytics to both help with the detection of suspicious patterns within large complex data sets and bring visualization and graph visualization at the forefront so that investigators can quickly understand the context around any entity of interest to make smart decisions. So that's what we have built at Linkurious, and we are very excited to partner with RS21. And now I will pass the baton over to you, Anne-Marie.
Thank you. Good morning or good evening, wherever you are in the world. Can everybody hear me okay? So like me, how many of you watch a lot of movies and TV and assume that our law enforcement agencies already have the data and tools at their fingertips to deliver swift and certain justice? As someone who can be accused of watching way too much CSI, I was surprised to learn that many organizations around the world are just scratching the surface when it comes to their data and systems evolution. And that's not to indicate a lack of commitment in any way. Innovative data strategies require a lot of time, money, and people. And crime has important implications for everything from quality of life for residents in a community to growing an economy and attracting and retaining talent. People want to feel safe, and we want to feel that our community leaders are doing the best that they can to do just that. And communities around the world are grappling with addressing crime. Criminal justice organizations are learning how to leverage better data analytics tools to enhance and streamline the entire criminal justice process, using data as a resource to improve community safety. So this use case began with a couple of simple ingredients. One, a criminal justice leader committed to leveraging data for better outcomes. 2, a business community interested in investing in projects that have a big impact on quality of life in their community. And then 3, technical expertise to be able to help them develop the right approach, the right strategy, and the right technology tools. Enter Quaro. So Quaro was developed to centralize and visualize criminal justice data to deliver data-informed insights to help improve the prosecution of serious crimes and to stall repeat offenders. The platform can be used to reveal previously hidden links between people, locations, incidents, and objects, and we'll talk about that a little more later. And these insights can promote and streamline data-driven prosecutorial decision-making. So Quaro really enhances rather than replaces the human element and helps empower thoughtful, just, and effective decision-making in that space. So the primary reasons for developing Quaro included data integration. The entirety of the platform integrates and analyzes data from various sources, allowing for a more comprehensive understanding of criminal networks and criminal activities. A second, efficient resource allocation. So by using Quaro to identify key players and connections within criminal networks, resources can be allocated more efficiently. This helps criminal justice stewards prioritize cases and focus efforts on those individuals who have a significant impact on crime rates. Proactive crime mitigation is another reason. Quarro enables criminal justice stewards to be proactive in their approach to crime fighting, analyzing patterns and trends and making decisions based on the data. Enhanced collaboration. It facilitates collaboration, can be used to better coordinate responses across multiple organizations that might be touching the process. And then ultimately, community safety. The goal of developing something like this was to enhance safety for all of us by providing insights to be able to disrupt those criminal networks. So, addressing human challenges can be complicated, of course, and there's not a silver bullet or a one-size-fits-all solution to addressing crime in our various communities and countries. The criminal justice system in the United States is a multifaceted and dynamic system that seeks to maintain order and enforce laws and administer justice, but its complexity can lead to challenges in achieving these goals. So the complexity stems from factors such as complex laws. They may be different from state to state. There are multiple stakeholders that are involved throughout the criminal justice process, all with different roles and interests. And each criminal case is unique. Several factors can influence the decision to prosecute, or perhaps an intervention or a consequence for someone committing crime. There's also resource constraints. So limited resources such as funding, personnel can impact the efficiency and effectiveness of the system. So sometimes we see this play out in delays or challenges in case management, for example. And then there's other influences such as balancing people's rights, public opinion, et cetera, that can add additional complexity to that process. So the visual you see here from the U.S. Department of Justice provides a general and simplified view of case flow through the criminal justice system. So on the far left, the blue box signals that a crime has been committed. So assuming that that crime is even reported in the first place, then the process might follow first an investigation. So agencies investigate suspected activity, they gather evidence, they interview witnesses, and potentially make an arrest. And so the suspect might be released or a case might move forward. Then there's a decision to charge. So prosecutors review the evidence and decide whether to file formal charges against the subject. And then that moves to pretrial proceedings. So this may include things like bail hearings, preliminary hearings, exchange of evidence, grand jury indictments, et cetera. And then it might move forward to arraignment. It might move forward to a trial and maybe even to sentencing and corrections. Before we get into the actual technical approach for the use case, I think it's really important to know that this criminal network visualization tool that we built is predicated on research that a small group of individuals in the population are actually responsible for an outsized proportion of the violence or crime being experienced in a community. And so this diagram from the National Network for Safe Communities is looking specifically at homicides, and it visually depicts this high risk and very connected population. The tool is connected to the idea that individuals are networked and in communication with each other, some way, somehow. That might be obvious, it might not be obvious. So some examples of this might be traditional gangs or drug trafficking organizations or terrorist groups or cybercrime networks and more. It could also be a group of friends or special interest groups formed via social media, or maybe very, very loose affiliations even. So really understanding how people are connected matters and gives criminal justice stewards insights that they may have been previously blind to. That leads us to the technical approach to building this criminal network visualization tool. So network visualization can be highly beneficial to communities in several ways, because first, it provides an enhanced understanding of networks and how they operate. So visualization helps law enforcement and criminal justice stewards in this case, and community members to better understand the structure and the dynamics of criminal networks. And so by being able to see the relationships and connections between individuals and groups, we can start to identify key players and patterns of activity that can ultimately inform investigations, prosecutions, and potentially other interventions. And second, it allows for improved decision making. So with a clearer picture of criminal networks, criminal justice agencies can make better decisions about how they're allocating resources, how they're planning interventions, and how they're prioritizing targets. And it increases collaboration because it facilitates the sharing of information. And that sharing and understanding can help align efforts and facilitate a more unified approach to tackling crime. It can influence prevention and deterrence. So when communities can develop more targeted prevention and intervention strategies, this can help deter potential criminals from engaging in illegal activities, and hopefully, because of those decisions, reduce overall crime. And it generates public awareness and understanding, and then organizations can evaluate and improve their efforts. It can be used to see if their strategies and interventions are improving things. And by tracking changes in the network over time, communities can assess the impact and make those necessary adjustments along the way. I'll now hand it over to my colleague, Brady Key, who will talk about our methodology and technical approach for building the criminal network visualization tool.
Cool. Thanks, Anne-Marie. So when RS21 got to approach this problem, one of the things that we realized right away was that the data is being collected. It's just not at the fingertips, at the forefront of being able to analyze and make these relationship connections that we want those in charge to be able to do. And so when we were approaching this problem, it was really realizing that gaining these insights either was incredibly tedious, being able to say, does this person have a relationship to some other person, and manually, like Jean was talking about, going through and making sure through tedious manual process, yeah, this person's connected through this person through these 5 different jumps, but it wasn't presented to them as this network connection existed. So it's either tedious or it was completely impossible because of disparate data systems. The data was collected but not mapped correctly, or there was data duplication, so not having good data integrity with the records that were being created and stored. So our approach to this problem from a data standpoint, we weren't really solving number one. The data collection was already happening. But what we realized was, if our end goal here is to be able to visualize the data in a network format, that the canonical relational database, think spreadsheet, Excel, storage of records, doesn't naturally transfer to a network visualization. So this second part of our approach of data storage and integration really starts talking about there's a decent amount of massaging that has to be done, of taking these relational database tuples and instead turning them into a graph network, essentially nodes and edges, which are the relationships between objects, nouns, and other nouns, and what was the relationship in between. And so finally, the 3, 4, and 5 part of this is our goal was to build a data platform where data analysis could be done through data visualization in a graph network. And that was the ultimate goal approach here. And so we took a stance of approaching it with what's called the pole data model. This is not a novel framework. It's standardized and utilized across many different realms. One of them that it's commonly used for is law enforcement, but also in finance sectors, you can see this model being used. And what the pole model does is it essentially takes nouns and puts them as nodes inside of a graph, and then allows you to have the relationship edges between these nouns. And the nouns that you are able to abstract in this scenario, in this pole model, is we have people. And in this case, that's a person in a case management system associated with law enforcement could be a defendant, it could be an agent, a law enforcement agent, it could be a victim, they could be a witness. So you can imagine the different roles that a person could play. But in the grand scheme of things, a person is a single distinct instance. And so that's what people are. Then the objects that you can start tracking is really anything that you can, very similar to a human, track in a unique manner. So guns have serial numbers, phones have IMEIs, and so being able to have the ability to say this is a single gun that was used in this crime and was used in another crime, because we were able to track it and make sure that there is some data integrity there. Another object that you can easily track in this relationship manner is cars, because we have VIN numbers associated with cars. The L stands for locations, and this is exactly what you'd think. They are physical locations in our geospatial environment. What's really, really interesting about locations here is that they show a large amount of data integrity issues. And here's why. Imagine that a crime is committed and an agent is documenting what happened, and they knew that there was a robbery at a grocery store, and the grocery store is on Main and Broadway, right? 2 cross streets, and it's on the southeast corner. Well, that agent very reasonably could go in and document, the crime happened on the southeast corner of Main and Broadway. Great. And they were insinuating that it was happening at a physical grocery store. Well, a week later, another crime could happen, another distinct crime, and that agent could go and say, oh yeah, this was happening at the grocery store name, and just put that in. It happened at the grocery store. They didn't physically say it was Main and Broadway, but they said maybe just the address of the grocery store. And then a third agent, a week in the future, could come back and say, oh, I know exactly the latitude and longitude point here, and so I am documenting the lat long. That's where the crime happened. Well, in reality, those 3 crimes happened at the same location, but they were tracked in 3 different ways. And so this data integrity problem, you can start seeing, exists with all 4 of these nouns. Actually, we didn't talk about events yet. Events are the crimes, so the incidents that are happening. But the data integrity for people is the same thing. If John Doe is the defendant and arrested on a case, and then another John Doe with the same name is arrested a week later, how can we determine if those John Does are the same person? Because when you're starting to build these networks, the data integrity is paramount to making sure that you'll be able to get any insights of any meaning out of it. Because if a career criminal is thrown into the system, but they are put in as and treated like it was the first time that they ever committed a crime, well, then you aren't even able to really get out of the poll model and the graph network anything unless that data integrity says, no, that John Doe is not a new John Doe. That is the one that has committed 100 crimes over the past 5 years, kind of thing. Okay, so data integrity is obviously a really big problem here. And so there are many ways that, again, we can solve this inside of a case management system to make sure that the graph network that we end up displaying and putting at the fingertips of our users is meaningful and insights can be gained from that. But it is not the core of this problem. The core of this problem is saying we need to make sure that what has historically been tracked as spreadsheet-like relational database records are actually stored in a node edge framework. And when we do that, you're able to start seeing things like John Doe was a defendant on a crime that had a victim, Jane Doe. And John Doe used gun 12345. Well, if we are collecting this data and having data integrity and unique records here, we can quickly start to see, oh, Jane Doe was a witness of a crime that happened a year ago, And the gun that was used on that crime was the same gun that was used against Jane Doe. So maybe you're starting to get insights that historically would have just been tracked as single discrete records in a database of, oh yeah, this gun was used, and not realizing that it was used on a potentially related crime in the past, which really starts you to allows users to be able to make these relational connections that historically were either, like we said before, tedious to find or downright impossible because they weren't even stored in the same data source, right? It was a disparate problem. So really, investigative insights can thrive once we start giving the relational networks of the nouns that they are already collecting, the people, the objects, and the locations of the crimes and the incidents that are committed. So identification of these patterns, the connections, they might not have been apparent when viewed in the less structured form, but now that we are able to use a graph database and implement Linkurious on top of it to allow us to visualize things quickly, cleanly, from a nice user experience, user interface standpoint, we're really able to make these relationships come to light. And so from that, I will go ahead and shift to a demo of the Quaro platform with Linkurious being the crime network visualization, and we can go from there.
Quaro's advanced prosecution module consolidates and organizes a detailed data collection on defendants, victims, weapons, locations, and other relevant information. First, data is entered into the system. In this example, we're interested in Eduardo, a defendant in 3 active cases. The advanced prosecution module cleans the data that is entered to ensure we do not have duplicates in the system and are indeed viewing a single defendant involved in 3 separate cases. The system sends this data in real time to the criminal network visualization application. Here, we can see our defendant, Eduardo, represented as a pink node that connects to other data points, such as co-defendants. Using the advanced prosecution module, users can search for additional defendants to bring up their networks in the criminal network visualization. Here, we're looking up cases for defendants Arturo and Josh. This is an especially useful feature when multiple cases are being worked together. Diving deeper into these cases, we start looking at the metadata, or collection of data entered into each case. Here we see a Volvo connected to Gustavo, an accomplice in Eduardo's first case, Brooks Rudolph, a new witness in Eduardo's third case, a car connected to Hector, Arturo's accomplice, a Smith & Wesson gun that Arturo is found with. In Josh's first case, we see he is also found with a gun, and in Josh's second case, we see Brooks Rudolph added as a witness as well. Now, we take a look at these same connections in the criminal network visualization, which reveals links between people, objects, locations, and events. As before, they appear to be separate, but when we add the metadata, including the Volvo, the witness, and the gun, we can see how these cases are actually part of a larger network. This is how the criminal network visualization takes what appears to be 3 distinct cases and reveals previously unseen connections that can inform action, such as new lines of questioning, evidence to consider, and other discovery information. The Quaro Criminal Data Platform brings together the advanced prosecution module and criminal network visualization to deliver novel insights.
Thanks, Brady. While we deployed this in the frame of reference of criminal justice, network visualization tools could be valuable in a wide range of industries and domains. So some examples could include things like behavioral health systems. So For example, in mental health and addiction treatment, network visualization could help identify patterns in patient interactions, networks of providers, and treatment pathways, enabling better understanding and management. Maybe first responders could use it to better connect those in need with the right services and organizations to help them. Maybe fraud detection in finance and insurance, it could reveal complex patterns of transactions and interactions that may indicate fraudulent activity or even potentially organized networks, helping to prevent those financial losses. And then disaster preparedness, network visualization can map out critical infrastructure, emergency response resources, and communication networks to improve disaster response and also discovery efforts. Other ideas, perhaps it could be deployed in the context of social media networks or supply chain management, public health, and more. So next steps, as you're thinking through this kind of thing for your own uses, a data-driven strategy changes the game for how organizations are able to understand their publics and their domains. And it's no longer a nice to have, it's a need to have. The organizations that invest in data outperform those that do not. And often we're so busy working in our businesses that we don't always have the time and resources to work on them. But a successful data strategy starts with asking the right questions. Don't skip the requirements gathering piece, the upfront research and analysis that really gives you the confidence to know that what you're building is insightful, intuitive, intellectually honest, and useful. So start with things like, what questions do you wish you could answer that you can't right now? What would you do differently if you had those answers? What data do you already have access to, and what data could you acquire to potentially enhance efforts? What skills already exist within your organization? Do you need new skills? Do you need added expertise? Do you need added capacity? Which leaders do you need to have at the table to make it all work? Which subject matter experts? And what new technologies or systems would help your team do it better? And how would you approach change management to be able to transition to a data-informed culture or workflow? I hope today that you'll walk away with a few key takeaways based on our use case example as you think through your own efforts and visualize data. A data-driven strategy, like I already said, really starts with asking questions central to your organization's mission and business processes. And then it progresses to analytical solutions and insights that allow leaders to make decisions based on what the evidence is telling them. Quaro is a great example of this because it enhances the human element and helps empower that decision-making. Network visualization is a powerful tool for allowing us to see those hidden connections that might be driving behaviors and act on those connections to work toward desired outcomes. And it's important to always be considering how you will maintain and improve your data systems over time. So this ongoing investment in technology and skills allows organizations to build their expertise year over year to achieve better outcomes. And it's not a one and done endeavor, it's a commitment to a regular line item. So with that, thank you everybody for your time and interest today. And Jean, can we kick it over to Q&A?
Yes, let's go ahead and get started. I see a few questions rolling in. Just as a reminder, if you haven't done so already, you can submit your questions on the right-hand panel of your screen. So the first question, what challenges did you encounter when applying these technologies to criminal justice efforts, and how were they overcome?
The volume and complexity of data can be overwhelming. So using Linkurious's graph analytics software and visualization that can process and visualize the large volumes of data was key in being able to deliver an intuitive and insightful solution.
Totally.
Brady, I don't know if you would add. Yeah.
Yeah, I mentioned it a little bit, but a lot of this relies upon data integrity. And what is a very common pain point with big data problems like this is that data can be not clean. And so you can have records that are tracked that are not associated with the same unique single source of truth, but they need to be. So a lot of our work at RS21 for this project was making sure that we could deduplicate a bunch of these nouns. Make sure that we know if this gun has a serial number, that it is the same single source of truth gun, and make sure that any copies get deduplicated and merged into a single record. So that was probably technically one of the largest hurdles that we had to overcome in order to glean the insights from the Linkurious tool.
Great. Looking at the next question here. How do you balance the need for comprehensive network analysis with privacy rights?
First, there are existing legal frameworks and ethical guidelines that govern data privacy and protection in the criminal justice system, in particular in the US. And to support those practices in the platform, we implemented security protocols and a user permissions hierarchy. So data is only accessible by authorized users, and activities within the system are logged for transparency and accountability. Brady, would you add to that?
No, you nailed it. Did you write this application in? That was it.
Okay, next
question. It's an important question.
Yeah, go ahead.
I just said it's a really important question.
Yeah. Next question here. What ethical considerations must be considered when using poll data and graph analytics in criminal justice and community safety applications?
Want me to take it?
Yeah, I can jump in. You start.
Okay. We spent a lot of time working with our client to create fairness and bias protocols to mitigate against exactly that, inadvertently reinforcing bias, for example, that could potentially result in any kind of discriminatory outcomes. So primarily system audits with a clear understanding of types of biases to account for. So some examples of that might be, say, implicit bias resulting in over or under representation of populations.
Okay.
Yeah, one of the things that was really important to us when implementing this tool was to make sure that there was no insights being provided to the user that wasn't data that was already collected, that we weren't utilizing machine learning or AI to say, hey, I think this person actually committed the crime for X, Y, and Z reason. It was never, it was very important that our goal was not to influence that. It was always just to say, this data has existed. It was entered by agents. It was captured in a way that has always been captured. And we are making sure to just display it to the agents to make sure that it's at their fingertips. We keep talking about information at their fingertips, wanting to make sure that that the relationship could be gleaned if they had the time and power to go and do it. But can we make it available to them without effort was the hope. And so it was a very important thing for us to make sure that this was not Minority Report, right? As cool as Hollywood is with all of these types of things, we didn't want to be on the wrong side of the ethical concerns.
Mm-hmm.
The ethics was certainly front and center in every step of the project.
Great, thank you guys. Next question here is, how much is scalability important for these kinds of applications? How many data points does a similar application manage?
Yeah, scalability is huge. What is really cool about Linkurious is that you don't have to be viewing the entire graph network at any given time. And so what you got to see in the database, or sorry, in the demo, is that while there could have been hundreds of thousands, if not millions of records in the source database, you still are able to interact with a very specific set. And so you can say, I'm just looking right now at the graph relationships that are associated with a single noun, whether that noun is an object, a car, a gun, or that noun is a person with a very specific role, or if that noun is an event, a case, a incident that happens. And so when it comes to Linkurious and the scalability, you're never dealing with the overwhelming, I don't even know where to start. This just, if the entire graph network was being displayed at any given time, it would look like a spider web, and it would be functionally impossible, overwhelming to be able to even navigate and glean insights from. But when you are able to, as a potentially investigator, go through and say, no, I want the ability to interact with a hyper-specific part of the graph and visualize that, the scalability really becomes endless, because now it's living in a database that can handle the scalability, but the visualizations are very specific to what you're actually looking for. Hopefully that answers the question.
Thanks, Brady.
Yep.
Next question. Does Linkurious consider itself as an OSINT provider?
So we're not a data provider, but we can definitely help aggregate any data sources, including OSINT data sources, in a unified knowledge graph. And we have a lot of clients that are mixing their own internal data sources with OSINT data to get a larger, enriched view of their counterparties, criminals, and more.
Great. Next question here, also for you, Jean. Does Linkurious work with the public sector?
Yep. I'd say it's a big part of our business, actually. So we are working with tax agencies, for example, HMRC out in the UK. In France, we are working with the French Employment Benefits Agency, and we are working with many more such public organizations throughout the world. So it's definitely a big focus of ours. We are also involved with national security agencies, but we cannot really name names here.
And another question for you, Jean. How is AI benefiting Linkurious, and what future developments within this context can its target market expect?
Sure. So we're definitely seeing a ton of interest in AI and graph analytics right now. So we integrate with the data science libraries of Neo4j, Neo4j GDS, and memgraph Maj, and through that get access to tens of such algorithms. And we have clients that are using that to score entities, basically try to identify the risky ones versus the non-risky. Using machine learning, graph analytics, and more to identify that. And we also have clients that are relying on those same algorithms to detect suspicious patterns and suspicious activities. So it's already a reality for some of our clients, the use of graph analytics and AI, and we want to push the envelope here. We are looking at things such as integration of unstructured data. That's an area where we think AI can help. We also interested in deduplication. I know that it was mentioned. We think AI can also be applied there. And finally, there's the whole angle of using AI, and specifically large language model, to help with querying the data in a more natural fashion.
All right, thanks, Sean. So it looks like we have a few more questions here. The next one's a little related to the scalability question that Brady, you answered, but let's go ahead and give it a go. What's the amount of data that the system is able to process?
Hundreds and thousands, millions of records. We did this very specifically for a client, and they had historical records in the hundreds of thousands. So we haven't stress tested it much further than that, but no issues there from a scalability standpoint.
All right. And where is the data stored? Does the tool retrieve data from a data lake or data is stored in the product's own database?
Yeah, so good question. For Quaro, it was in our product's own database. We didn't do a data warehouse for this. There was a very specific historical set of data that we needed to make sure was brought in, cleaned up, so that it could be navigated in this graph database format. What was interesting, though, is that the relational database still needed to exist. The case management system that drove the collection of all of this data was somewhat apart from the graph visualization piece. And so the relational database and the tuples and how that interacted, similar to the chart that Anne-Marie showed, that the case management system for the United States is this really almost, I hesitate to say convoluted, but very complicated choose your own adventure type path, where so many different, from the start to the end, could take so many different turns. And so the case management had to still be collected in the way that it was necessary for our client. But what was really cool was we were able to utilize a graph database where we were able to take those relational database records, turn them into nodes and edges, and then that is what we were able to display and have Linkurious visualize for us.
Great, thanks, Brady. It looks like there's just one more question here. It says, what do you use for master data management to ensure, for example, that every location uses the same format?
Yeah, so the data duplication problem, like we talked about, was one of the biggest hurdles. At first, we tried just making sure to give the users the ability to say, I know that these are duplicate pieces of information because of knowledge that I have outside of the system. Again, not necessarily wanting to utilize some sort of AI to make sure, or to insinuate that this John Doe 1 is actually John Doe 2. We really wanted that third party human interaction to make that relationship. However, we do know that there is unique fields associated with each one of those nouns, right? Maybe John Doe just had their name misspelled, or they got married and their maiden name is no longer their current last name. And so realizing that those two pieces of information, that might be something that can be done in a master data management system. So we've looked at prophecy. This is name dropping, but prophecy for master data management has been utilized by RS21 in the past, of being able to say, we need unique records here. We need to be able to solve and resolve these data duplicates. And so a whole plethora of things that we have tried, some wrapping our own, some using third-party tools like Prophecy, and then everywhere in between.
Great. So it looks like that is it for questions for today. So we do want to thank you all for joining. And of course, a special thank you to RS21 and our guest speakers, Anne-Marie and Brady. This webinar was recorded, so we will be sending it out to you as soon as it's available. But of course, if you have any questions in the meantime, feel free to reach back out to us. So that's it for today. Thanks again, everyone, and we hope you enjoyed this webinar.
Thanks, everyone.
Thank you all.